These are in listen-only mode.
Good morning, everybody, or good afternoon. My name is Win Fu from the Field Force Management Integration Interface PC Chair. We have a webinar today on the work that we've done past year on the specification development of the FFM interface. Today I have a group of experts in the call that give us an overview of the work package and the detail of the interface of each of the modules. So I'll start introduce. I have Johannes from Rosen. He will give us the detailed technical part. And then I also have Israel from Click Software. He will give us some of the use cases. And Juha from Oslo University also will give us another use case of how this interface has potentially have applied to the real-life scenarios. The plan for today is basically we'll try to do a presentation within about 35 minutes or less, and we'll leave some time for question and answers at the end. So if you have questions during the presentation, please type in to the chat board, and we can take those questions at the end, and the chair from OASIS will moderate that. First, I thank OASIS to give us the opportunity to give this as a broadcast to the large community of our work. So with that said, let's go to the next slide, Johannes. All right. The overview of our work package, we divide up to two parts. First part is the what we call it in OASIS is non-standard track. But basically, it's a document or specification that cover all the business use case, the motivation, and some of the high-level features. We capture all of those, and we also try to develop a requirement that is from a business side and also from a functional feature side. So that's the document we capture within there. From there, we develop the specification, the detailed specification of the interface. Also, the result from the specifications, we also generate all the XML and web services documents so that can support our specifications. To the right-hand side of the slide set, you have a little figure. This one, when we designed the specification or the interface, we want to make sure that the package that we release is modular and be able to adopt other requirements in the future. So we lay the requirements and the functionality into layers, and the document is kind of layers in the figures that you see here. So it's easy to modify some of the key components. Johannes will go into detail of the specification of each of these modules in the next set of slides. But the beauty is that this also, when we develop this, we specifically do not want to bind to specific transport. So we have, we have data models. We have each of these data models and the interface, but we also have some recommendations for the transport of our protocol. So later on, again, people may wish when they implement out there, they can put different transports as they wish. Okay? So let's go next slide, and when we go to the next slide, I will pass the presentation to Johannes from Rosen to give us a detail. Johannes, go ahead.
Thank you, Tat. So my name is Johannes Lehtinen, and I'm from Rossum. Okay, let me first introduce you some of the business drivers behind the FFMTC work. The integration of field force management into surrounding IT environment tends to be costly and a time-consuming undertaking. And the fundamental reason is the high level of variation in requirements. Both the fieldwork information content as well as the workflow and the processes may vary, and not only from one business sector to another, but also between individual businesses. And this is a challenge for the integration interface because field force management is not only about terminals and user interfaces, but ideally the field force management system should act as a kind of an extended arm of the work planning system when it's reaching out for the addressable field force. So the field force management system must be able to convey a versatile information content and to also support and enforce case-specific business processes. So how we are addressing these challenges with the field force management integration interface? It provides a flexible interface between enterprise resource management and field force management systems. It provides a data-centric approach that allows not only the fieldwork information content but also the field processes to be dynamically modeled and specified over the interface. This also makes the integration challenges more manageable by providing a layered approach and enforcing clear separation of concerns between the systems. So the enterprise resource management system is responsible for scheduling and supervising the work and sending it over to field force management system, which is then responsible for field communication and of course also returning information back to enterprise resource management. The most important and probably also the most challenging design goal was the applicability across domains and use cases. The interface should be flexible enough to support fieldwork modeling for very different kinds of use cases. And this applies not only to fieldwork information content but also the process flow. Technical scalability is important because the field force may involve thousands of field workers. So the interface must support efficient communication between the systems. Feature scalability means that not all features are necessarily required in all deployment contexts. So the interface has a lot of features, but many of those are optional. So it also can support solutions that implement or use only subset of the features. Expression accuracy and user guidance means that the interface must support whatever level of detail is required by the particular use case. For example, to prevent delays or mistakes due to missing information, or on the other hand, information overload. And the process flow may also range from very simple tasks to sequences containing a lot of subtasks and steps. So the interface must enable the field force management system to provide appropriate user guidance and to also enforce the correct process flow. Reliable message exchange that's of course important, so that correct data is delivered to and from the field and any updates are processed correctly. Deployment adaptability and technology neutrality means that we make minimal assumptions regarding the deployment environment, and the technology neutrality part is important so that we the implementations of systems using the interface can use whatever technology is suitable. Okay, and as Tad mentioned, the approach we took with the FFMTC was that we came up with a set of example use cases and then used these use cases to derive the detailed requirements for the interface. And in this webinar, we will be presenting you a couple of these use cases, but you can use you can find all of the use cases in the requirement specification that the TC has published as a committee note. So this first example use case is a field service installation and maintenance type of use case. And the details are based on telecom installation job, but most of the features apply to other kinds of installation and maintenance work as well. So the installation company receives installation jobs from several telecom operators. And this means that the work request structure and also the reporting requirements may vary between work received from different telecom operators. For example, the field work information details and work instruction details may differ, but also the process flow may be different in part. And of course, different operators might accept different kind of reporting and resolution codes back. Also, single job may involve several locations. For example, a distribution point, one or more cross-connect locations where copper connections are made, and finally end-user premises where device installation happens. And single installation may also be split to several assignees, so that one assignee goes to cross-connect location and other assignee goes to end-user premises to the device installation. Of course, information sharing among field force here is critical, so that if the same job is split to two assignees, they must be aware of the progress the other assignee is making. Field-initiated requests mean that the assignee can make a request to the enterprise resource management, so that the request is not necessarily associated with a particular work request, but for example to find more available work if the assignee completes all of the work ahead schedule, and then perhaps reserve one of the offered jobs to the assignee. Okay, then if we look at the data content and structure of what it could be for this example use case. First of all, it's important to realize that the FFMII interface does not dictate particle visualization for the data. So the visualization details are up to the implementation, and this slide is just showing you what kind of data structure the FFMII interface supports, not an example of visualization. So the work request has a set of data forms. For example, here the header data form contains identification information that can be used, for example, on list views in the user interface. And the overview and instructions forms provide additional details that the assigner will need to perform the work. And the idea here is that the data content for each of these data forms is dynamically modeled and specified over the interface. So there are no particular fixed fields that should be present, but the interface supports dynamical modeling of data form content. For example, FFMI interface supports different types of data such as textual data, numerical data, dates, and timestamps. But it also supports more complex data structures. For example, here we have on the left in the overview box, you can see a subscriber data group containing a set of data fields that are related to the customer. It also contains a products list that is an example of tabular data that FFMII also supports. And finally, there can also be binary attachments associated with the work request, for example, to provide additional documentation or instructions. And then, while the FFMII user interface does not go into details when it comes to visualization, it provides, it allows the enterprise resource management to provide some visualization hints for the field force management. For example, the phone number field in the subscriber data group can be marked as being a phone number, so that, for example, the user interface can implement click-to-call functionality. Similarly, the route in the instructions box on the right can be marked up as containing pre-formatted textual data. Okay, that was the data structure. Then when we take a look at on the workflow of the work request, a work request can have one or more activities, and these activities are distinct parts of the work to be performed. In this example, there is a connect activity for copper connection work and an install activity for device installation work. And each of these activities may be assigned to different assignees. They can have different locations, and they can have different kind of scheduling constraints. And the workflow is modeled as a state model associated with an activity. And this state model also is fully dynamically modeled and specified, so there's no predefined state model that has to be followed. In this example, we have a state model where, for example, the connect work starts in the new state, and when the assignee starts the work, it goes to ongoing state, and finally, when the assignee says that the work is ready, it goes to completed state. And there's also a possibility to suspend and resume the work. Now these activities can have different state models, and they may also have dependencies on each other. For example, in the install activity, the start action depends on the connect activity having reached the completed state first. So it is possible to have activities that are either parallel or that are to be executed in some predefined order by introducing proper dependencies. Also, like on a work request we have those data forms, it's also possible to associate these actions with input forms, specifying what input data must the assignee provide as part of taking an action. For example, here in the ready action, we have defined that the assignee must provide the device class and resolution from a predefined enumerated code set. Also, it's possible that some of the input fields are enabled only if a particular condition is met. For example, in this case, the SLA for each reason and explanation are asked only if the current time is already past the SLA target time. Okay. Then some of the highlighted features of the FFM-II interface in general. So multi-tenancy, we will talk about that in detail on the next slide. A data-centric design means that the FFM-II interface only contains limited number of operations that need to be implemented by the systems implementing the interface. But on the other hand, the data model being used is very flexible, and for example allows the work request management to support dynamically specified data content or also data structure that can be dynamically specified over the interface, and to have multiple activities with dynamic workflow and dependencies like described in the previous example. It also supports these field-initiated requests. So in addition to the previous example of querying for more available work, they could be used, for example, to enable or disable a particular device, perhaps power off or power on part of the equipment, or to simply report things such as absence to the enterprise resource management. For example, that the assignee has become sick and cannot work today. The reference data management provides a unified interface for managing background information and reference information. For example, the field force or the addressable assignees are defined using the reference data management interface, but also the available work types and the field-initiated request operations are configured using this same reference data management interface. And it can also be used to manage data that is shared by multiple work requests. For example, a set of codes to be used for reporting or binary attachments that may be shared by multiple work requests. Okay, now back to the multi-tenancy topic. It means that the FFM interface supports very flexible integration topologies. On this slide, manager means the part of the enterprise resource management that implements the FFM interface, and implementation means the part of the field force management implementing the FFM interface. So, for example, there can be several managers sending work requests to the same implementation to address the same shared field force. So an assignee could receive work from two enterprise resource management systems. On the other hand, an enterprise resource management system could also send work to two different field force management systems, for example, to address different parts of the field force. Okay, then some of the most important entities in the FFM domain model. The two most important entities are work request and work type specification. Together, these two define a task to be performed on the field, and it has a set of assignees and scheduling constraints associated. The idea of work type specification is that the work type specification defines the structure of the work request. For example, the data forms, what data fields are there on each data form, what are their labels, display labels, what types of data are associated with them, and so on. Work type specification also defines these state models, the states, actions, and steps. And what work request does is that it refers to the work type specification for structure of the work. Typically, multiple work requests share the same work type specification. For example, installation work could have one work type specification and maintenance work another. So the work request fills in the data forms specified by the work type specification with actual job-specific data. And it also specifies the assignees for the activities and scheduling constraints for the work type specification provided activities. Other important entities are work request status record, which records a complete history of the work request, including all updates and operations that have been performed on the work request. A field-initiated request was, it's actually quite similar to work request, but going to the other direction. So it's a request initiated by the assignee and sent to the enterprise resource management system to perform some operation there. And there can be two types of requests, either topical notifications that are just requests to the enterprise resource management but do not return any data back, or topical inquiries that actually return information back from the enterprise resource management system. And reference data was this common data shared by multiple work requests, such as code sets or a set of attachments that can be bound to work request, for example, based on what devices are associated with each work request. Okay, and then a more detailed look on how these state models are dynamically specified and how the field process and workflow is managed in the FFM interface. On the left, you can see the rectangular boxes are high-level states that the enterprise resource management likes to track. For example, you have state A and state B. And the rounded boxes inside them are individual steps in the workflow. So there can be multiple steps associated with the same high-level state. And the transitions between the steps are the actions that the assignee takes. And the workflow may have also alternative parts. For example, here the assignee in step 2 may make the decision whether to repair a specific part or whether to replace it. And the challenge here, having this very dynamically modeled state model, is that the field force management, of course, must have some knowledge about what is the semantic of the state model. And that's why we have associated a predefined status category with each state. For example, the state A has been associated a status category open, meaning that the work is not being actively worked on, but it's still open. And the state B has been associated with status category active, meaning that the assignee is actively working on performing the work while it's in state B. So this makes it possible for the field force management user interface implementation to properly visualize the current state of the work request, but also to support and provide guidance for the assignee. So this completes my part of the presentation, and next up is Mr. Beniamini presenting you another example use case. Thank you.
Hello everyone, Israel Beniamini with Click Software. The asset management use case shares a lot with the use cases we saw before. However, it emphasizes some of the more complex processes and workflows that are required in asset management that you can find in electricity utilities when you need to maintain the transmission cables as well as the substations and generation equipment. Of course, you can see it in many other places, in telecommunications and others. The most important thing is to keep everything working, both when something unexpected happens and also when you have the normal maintenance that you need to have. So much of the work is done with a lot of planning in advance, with crews. The work may take 20 or 200 steps, and they involve crews of 5 people or 50 people. However, the crews can change over time, and also each member of a crew may also have some tasks that are not related to that crew. So we have a lot of flexibility in how we push jobs to specific people or specific crews, but we must still enable strict rules, mainly for regulation and for safety. So we must make sure that we obtain approval, and we make sure that the electricity is shut down before entering some workspace, for instance. So there's a lot of importance to communication between the crew members, which is not done directly, it's done through the manager, and to making sure that until the communication is done properly, we do not go into any place that is dangerous in any way. Other things that are important are that many sites have more than one asset. And so when you go to that site, say it's an electricity substation, you may notice that something else needs work. And again, for many reasons, you cannot just go ahead and perform that work. You have to create this work request, or more properly, to send the message to their manager software to create this work request. And then, if everything is approved, it will go back to you, the technician, as a job to be done. While doing all that, there might be an emergency somewhere else. So we need a way for the workers to suspend their current work and push them down into some stack that they go to the other work and possibly come back and do it, or possibly some other person will take over continuation of that task. Lastly, there is a lot of information that is collected during this kind of work. When you replace something, you write down the situation and the reason and the serial numbers of the part that was taken out, the number of the parts was brought in. And for this, FFMII needed to support both a very rich data model and the way to enforce this collection of information. I hope this gives you an idea of the complexity of such scenarios and the reasons why FFMII was specified to support all of this. Thank you.
Hello everyone, this is Juha Tiihonen from Aalto University. I have some discussion about data collection from the field. So we always record timestamps of different activities and steps as they happen. But in addition to that one, there are many other inputs as motivated by Israel. For example, maintenance personnel often carries a number of spare parts with them. For billing and restocking purposes, it is necessary to identify any used spare parts. When equipment is installed, it may be necessary to record the serial number. FFMII supports manual entry, scanning barcode, or using RFID. This input may be connected to a more complex workflow. For example, identification of a cable TV set-top box and pay TV card may be used as part of the provisioning process to link the card and device together. In context of corrective maintenance, it may be desirable to collect failure and maintenance details. For example, the failed component or components are to be identified and occurred failure mode and failure mechanisms recorded if known. In case of oil and gas industry, standards define extensive information to be recorded for maintenance activities. Similar but less detailed requirements exist in service business related to heavy machinery. Some fieldwork, such as overhauls or maintenance inspections, include measurements. Results are to be recorded in context of the equipment or component in question. To address these needs, FFMII supports data forms that may contain input data fields of numerous types. Supported types range from simple textual inputs and numeric types to time, duration, or GPS coordinates. It is also possible to collect attachments such as images through a camera, signatures, or barcode data. Naturally, FFMII supports validation of input data. Validation conditions are arbitrary Boolean expressions that determine the validity of input in the current context. For example, validity may be dependent on other inputs. It is possible to dynamically require information input only when such input is relevant based on context and other inputs. Enable and updatable conditions specify if data elements are visible and if input is required. For example, information about a service level agreement breach is collected if and only if the SLA breach has occurred. Tabular input is supported through the concept of data matrix. Further, a hierarchical selection tree may be associated with the data field to assist the assignee in selecting a correct value among a large set of valid alternatives. For example, a component in product structure or bill of material can be identified by traversing the product structure. Similarly, spare parts can be organized in a tree and parts used in corrective maintenance are recorded. For example, spare parts codes could be organized into a selection tree where the first level could be a device category, the second level a device type, the third level a device model, and the fourth level a replacement part code. As a summary, FFMII provides flexible and dynamic means for collecting validated and relevant data from the field. The next slide please. On this slide is references to our documents produced by the technical committee. We have the requirements specification, the actual interface, and a complete package that contains all this stuff. Yes, and on this list of contributors, you see that the technical committee had representatives from work planning, field force communication, and from academia representing their respective companies and universities. And now it's time to say thank you, and it's time for questions.
Thank you very much, guys. That was great. That was great. Okay, we've got some time, and I have a couple questions here. The first one is, does the interface support offline mode of field operations if no connectivity is available?
Yeah, this is Johannes here. Yes, the interface has been designed to support offline mode of operation. For example, it makes it possible to specify as part of the workflow that some action makes updates to the information content of the work request. So this can be used to make those updates offline without first consulting the enterprise resource management. Now, of course, this interface does not dictate whether offline mode of operation needs to be supported by the field communication system, but that's up to the field force management implementation.
Okay, thank you. Okay, so we did talk about this, but follow-up question on real-life experience. I guess specifically anybody on the panel today, your real-life experience using FFM2. That'd be great, so we could just go around.
Yeah. Well, if I may continue, Johannes here again, we have been using the predecessor of the FFMII interface in production with some of our telecom customers, and we have taken that real-life experience to further improve the prototype interface and brought those improvements here to this specification that is now being made available.
This is Tadwin Fu from NFN. In case us also, we have some real-life use case out in the customer field. Due to the fact that this is a new interface, new specification, the implementation that we have on the field not exactly comply to the current specification, but we anticipate in the near future we have some support for it.
Okay, anyone else? Okay, so Johannes, you just touched on this, the types of mobile users that are supported with the interface. You just talked about that. If you want to elaborate on it, that would be great.
The types of user interfaces that are supported, or the user interface modes. The FFMII interface has been designed to not be specific to particular user interface implementation technology, so that it would work, for example, with mobile interfaces that are based on browser-based technology, or on mobile client applications. And it even has some level of support for very minimal interfaces such as text messaging. For example, the interface supports that you can specify short keywords for data fields. So it even might support implementations that have very limited communication capability. But in general, the goal has been to make it general enough to be able to support a wide range of communication and user interface technologies for the field user interface.
Right, very good. Does anyone else have anything to add? Okay, so, part of the reason that we do these webinars within OASIS, obviously it's an educational tool, but the other thing that we're doing here is this is sort of a call to arms. We invite everyone that's on this webinar. I will follow up with you individually and send you the link to the recorded version. But again, this is an opportunity to potentially participate with OASIS, bring your implementation and share it with the group. We're always looking for more implementations, and I'm here to answer any questions, and any of the gentlemen that presented today are also available. So I would like to thank our presenters. Thank you very much. You did an excellent job. And also on behalf of OASIS, thank the attendees for taking time out of their day to join us. Thanks, everybody. Have a wonderful day.